I have the pleasure of chairing the final session today. So we have half an hour in which we're going to hear from a distinguished speaker. We're going to have a little bit of celebration, some awards, and I expect there's going to be some belly rumbling along the way. So I will make sure that we finish at 1 p.m, I promise. We have to speak to you now, Jamie Tarlton from the Climate Change Committee. The Climate Change Committee is highly important, does some really highly important work and has done since 2008. I find they really help to be our kind of guiding star for the relevance, the role, and also the kind of styles of CCS, whether that's for mitigations or for removals. As well as being a kind of a north or a guiding star, they're also a carbon doctor. They keep doing regular health checks on our progress, and it's not always positive. So I'm really interested to hear from Jamie now. Jamie Tarlton coordinates the Climate Change Committee's work on carbon capture and storage and also coordinates the CCC's work on the emissions trading scheme. So we're really lucky to have the final 20 minutes of the floor. It's over to you.
Cool, thank you for that. Yeah, thank you all for having me. It's been really interesting being here and listening to what's going on in the CCS space. I wish I had more time to think about CCS, but sadly we've got so many other things we need to work on as well. So yeah, it's been really interesting. Thank you for the introduction of the CCC. Just to kind of add to that for people who haven't come across us before, we advise the government on all things climate change. So this is both on the mitigation side and on the adaptation side. So that's on how to stop climate change and then how to adapt to it as well. And the work I'm going to talk about today is our work on the 7th carbon budget. This is a climate change target for the period 2038 to 2042, which we have just given our advice to the government on what that should be. And as part of that work, what we've done is we've developed a pathway showing how to get to net zero from where we are today, and then using that pathway to say what emissions should be during that period as a guide. So it's going to be in two parts of this presentation. Firstly, I'm going to start off talking about the overall 7th carbon budget pathway, how we get to net zero. I'll point out bits that are relevant for CCS along the way, but a lot of it's going to be very kind of broad, cross-cutting stuff. And then in the second part, I'll zoom in a bit more on the CCS side and look at how CCS plays a role in that, where the CCS is in terms of the different sectors of the economy, just to kind of emphasize its role there. So to start off with my kind of broad introduction to our 7th carbon budget work. This graph here shows emissions in the UK, both historical and future, and also shows all of our climate change targets to date. Now, if we start with the historical, you've got the grey line, which shows emissions from 1990 to 2023, I think. And you can see that there's been a lot of progress to date. Emissions have gone down by about 50%. And you can see that the rate of reduction has gone up as well. So from 2008 onwards, which is when the Climate Change Act was passed, the rate of reductions has about doubled since then. This is largely due to reductions in the electricity supply sector, mainly from the closing of coal power stations and the replacing of those power stations with gas and renewables. And you can see the previous climate change targets are the orange bars, first, second, and third carbon budgets. And we have met all of those 3 carbon budgets. So this is really a success story to date. Now, if we look into the future, we've got the purple line here, which is our so-called balanced pathway, which is our kind of vision for how to reach our overall net zero target in 2050. And you can see this hits all of our existing climate change targets. It hits our 4th, 5th, and 6th carbon budgets, and also our 2030 and 2035 nationally determined contributions as well. And then, as I said earlier, this line is what we use to recommend our 7th carbon budget target, which is the purple bar. So what goes into this balanced pathway? This graph shows reductions in emissions over time, both historically and in the future. Now, if we start with the bar on the left, this is the first 3 carbon budgets, which have already been hit. And you can see that most of the reductions, as I mentioned before, have come from the energy supply sector, with a range of contributions from the other sectors as well. But this is really a success story for the electricity supply sector. Now, if we look to the next bar towards the right, we can see that for the next 3 carbon budgets, the picture changes a lot. We can no longer just rely on the electricity supply sector to get our emission savings. And this is because we've already plucked those low-hanging fruits, so to speak. And so it gets harder from now on to get more emission savings out of them. And that means that other sectors, such as surface transport and buildings, need to play a much bigger role in hitting these targets. Taking another step to the right, you can see our 7th carbon budget reductions. And electricity supply is an even smaller reduction than before. Surface transport and buildings are still important. And you can see some other sectors that are starting to get more important. You've got engineered removals at the top. Obviously, CCS is very important for that sector. And we've got agriculture and land use and aviation as well are starting to pick up. And then finally, for that last stretch to get to net zero in 2050, we can see electricity supply has gone down, as has surface transport and buildings. And now it's really a story for engineered removals, agriculture and land use, and aviation, which are those bars at the top. Yeah, so you can see engineered removals, like I say, most of that will come from CCS, as I'll go into in a bit more detail later. So really important to get that chunk of emission savings. You saw this graph about an hour ago in the CCSA talk. This is another way of looking at emissions reductions in our pathway. Rather than looking at it by sector, looking at it by abatement type. So you can see the biggest chunk in this is electricity. So this is from decarbonising our electricity supply and also electrifying different areas of the economy, mainly electric vehicles, heat pumps, and also some industrial electrification as well. Sorry, stumbling over my words. And then there are other areas which are playing a more supporting role. In terms of where CCS plays a role, you can see that there is a CCS bar in this. It's one of the red ones. You've got the engineered removals one, which is mostly CCS. And I think there's a little bit in the electricity decarbonisation one as well. Now, if we look at those residual emissions in 2050 to get a picture of where they are in terms of different sectors and what we're doing to mitigate them, you can see the bar on the far left is all of the different sectors. And you can see that the orange dot, which is total emissions, gets down to net zero. And then we've got this bar split into 2 parts. We've got the land sectors in the middle, which is the agriculture and land use sectors. And then we've got all others on the one on the far right. Now, the reason we split it like this is to show that there is a rough balancing within each of these 2 groupings of sectors. So your land sectors, you've got agriculture is more or less balanced by land use reductions. And then you've got all other sectors which are more or less balanced by engineered removals. Now, CCS comes into this bar on the far right. Engineered removals is mostly from CCS. And what you can't see in this is the contribution that CCS makes to decarbonising the other sectors. So you've got some small industry and waste emissions left. But without CCS, those would be much larger. And also other sectors such as energy supply have gone down a lot, which is partly thanks to CCS as well. We haven't just looked at how emissions behave in our pathway, we've also looked at costs. This graph summarises those costs. Now you can see that the overall costs start off positive, and then about 2040, they switch to going negative. So you can think of this as, if we invest now, then we will get those savings in the future. So it's not just a negative, this is going to cost us money picture, we will get savings in the future. These costs are distributed very differently between the different sectors. You've got the building sector, which is a net cost throughout the pathway, although you do get some operating savings, which equates to saving people on their bills at home. Electricity supply is a net cost to start with, but then as you go forwards, you get a net saving into the future. And then surface transport is mostly a net saving throughout. You've got a small net cost at the start, but then as you get electric vehicles coming out, you get these net savings in the future. And in terms of where CCS fits in, you've got some in the electricity bars, but most of the cost is going to be in these other bars, the red ones at the top. Now, the reason I point CCS out is because these red bars are relatively small compared to everything else, and CCS will only be part of those bars as well. Just to emphasize that, people talk about how expensive CCS is, but actually in the grand scheme of things, compared to all of those other costs and savings, it's not so big. But I would just emphasize, as you all know, costs are very uncertain when it comes to CCS, so we may be wrong here. You know, it may be more expensive or cheaper depending on how things go. These graphs show our balanced pathway split by sector. So you can see how each of the different sector emissions lines behaves. Now, most of them start off at a large number on the left in 2025 and go down close to zero in 2050. There are a few exceptions to this. So agriculture and aviation, as I said before, have substantial remaining emissions in 2050. And those are cancelled by negative emissions in the land use and engineered removal sectors. Okay, so now I'll move on to looking in a bit more detail how CCS fits into the picture. This graph shows our CCS over our pathway, split by different sectors. Now you can see it's a roughly linear increase starting in 2028 and going out to 2050. But there's quite a distribution between different sectors. Engineered removals we see as the kind of largest of the different sectors in terms of its dependence on CCS. There is some engineered removals that doesn't need CCS, but most of it does. And then we've got a few other sectors as well. We've got electricity supply, industry, fuel supply, and waste as well. Now, if we compare this to our last advice report, which was our 6th carbon budget one, if anybody's read that, you might be wondering why our CCS has gone down compared to what we said 5 years ago. Now, the main answer to that is because our engineered removals pathway has gone down as well. This is partly because we see opportunities, like more opportunities for decarbonising the other sectors and reducing those residual emissions than we saw 5 years ago. And partly because we were heavily dependent on biomass imports in our last pathway. So this is growing trees and other biomass in other countries outside the UK and importing them into the UK to use them for our engineered removals. And we wanted to reduce our dependence on those imports. You can also see that fuel supply is a bit smaller than it was when we did this 5 years ago. That's because we see less of a dependence on hydrogen than what we saw 5 years ago and more electrification instead. And then the other 3 sectors have actually increased very slightly. So now I'll zoom into each of those different sectors, starting with engineered removals. We've got 2 parts to this. We've got bioenergy with carbon capture and storage and direct air carbon capture and storage. Most of this is BECCS rather than DACS. That's because we see BECCS as a cheaper option for getting these engineered removals, with DACS being a more expensive one. And we see it starting earlier than DACS as well. This is because we consider it to be a more mature technology. We already have biomass combustion plants out there, such as DRACS. So we see retrofitting those with CCS as a kind of relatively straightforward thing to do. Whereas with DACS, it's a much younger technology. We know it works. There are demonstration plants out there, before anyone kind of tries to correct me on that. But we think in terms of getting that out at scale, we think 2035 is a more realistic start point for that. However, you can see a difference in the distribution between them here. So with BECCS, you can see it's a much bigger chunk of it, but as we get out to 2050, it's starting to slow down. Now, most of this slowdown is because we are essentially running out of biomass that we can use in BECCS, you know, given that we're trying to reduce our imports of biomass. So we're kind of nearing a saturation point there in terms of how much we can achieve. Whereas with DACS, you can see it's accelerating out to 2050. Now, we haven't looked at the picture after 2050, but if you were to, then you could see DACS potentially continuing to accelerate after that. So past that point, it could potentially get even more important as time goes on. Next, to look at industry. There's 2 subsectors here that use CCS in our pathways, cement and lime and chemicals, and it's a roughly 50-50 split between them. Yeah, and both of those were increasing, so it's a kind of fairly straightforward pathway there. There's quite a few step changes in terms of, you know, from 1 year to the next, kind of a jump in CCS. That's because our industry modelling generally models emitters at the site level. So the model will say, okay, in this year, this plant gets connected up to CCS, and so that's why you get a jump. Obviously, there's uncertainty on that, like it might be a year earlier, it might be a year later. That will depend on a number of factors, but yeah, that's why we have those step changes here. Moving on to fuel supply. Again, we've got two subsectors here. We've got low carbon hydrogen supply. So this is methane reformation to produce hydrogen, and fossil fuel supply as well. Now, both of these are a bit interesting because you can see that they both peak in 2045 and then start to decrease after that point. Now, for low carbon hydrogen supply, this is because as time goes on, we'll get more and more renewable electricity scaling up, and that will increase the cost effectiveness of green hydrogen, which is using electrolysis with green electricity to produce hydrogen. And towards 2050, that starts to displace some of this blue hydrogen and means that we've got less CCS happening here. In fossil fuel supply, as you might expect, in our pathway, we've got less fossil fuel use as time goes on through to 2050. And so you reach this tipping point in 2045 where, the production of fossil fuels is decreasing, quickly enough that it kind of crosses over this point, and you start to get less CCS happening as a result because there's less stuff that you can fit the CCS to. And then finally, the last two sectors, which I've put on one slide to save on slide space. We've got electricity supply and waste. Both of them just have one subsector. Electricity supply is gas-powered CCS, and waste is energy from waste. Now, I think most of this graph is fairly straightforward. They're both increasing over time, with one exception, which is you might see a dip in the electricity supply CCS in 2032. This is because we see Hinkley Point C coming online around then. So there's less need for this gas-powered CCS at that point. But you see after 2032, it starts to increase again. So it's overall, the picture is increasing over time. And this is my last graph, my last slide even. And this again looks at the total CCS in our pathway. But instead of being split by sector, I've split it in a different way here. I've split it into the CCS coming from fossil fuel production and use for energy, which is the purple bar, and all other applications, which is the orange bar. Now, the reason I put this up is because I know a lot of people link CCS to the fossil fuel industry, and I think a lot of people in the public assume that CCS is just being used for reducing emissions from the fossil fuel industry. I just want to make the point that in our pathways, that is far from the case. You can see that most CCS is actually happening in other applications. And fossil fuel production and use is an important wedge in that. But it's not the whole picture. CCS is really important across a wide variety of applications. And that's it for me. Thank you.